About 4.5 billion years ago, a Mars-sized world astronomers now call Theia slammed into the young Earth at a steep angle, and the debris that got flung into orbit eventually cooled into the moon hanging over your house tonight. So when people ask what would happen if we swapped the moon for an actual planet, the honest answer is that we already ran a version of that experiment once. It just cost Theia its entire existence and reshaped Earth's rotation, tilt, and tides in the process. This time, instead of a random cosmic accident, let's choose 9 different worlds on purpose, starting with the smallest scrap of rock in the asteroid belt and ending with the largest planet in the solar system, and walk through exactly what each one would do to your sky, your oceans, and your odds of still being here afterward. Start with the smallest option on the list, because it's also the one that gets ignored the most. Ceres is the only dwarf planet sitting inside the asteroid belt, wedged between Mars and Jupiter, and it's barely 940 kilometers across, about a quarter of the moon's width and under 2% of its mass. Slide it into lunar orbit and the change would almost be insulting. On a clear night, you'd need effort to notice anything, just a pale smudge instead of the bright disk you're used to. Tides would collapse to a fraction of their current strength, and that sounds harmless until you remember entire coastal ecosystems, from mangroves to tide pools to spawning cycles in shallow water, are timed around that daily rhythm. And total solar eclipses would disappear permanently. Ceres simply isn't wide enough to fully block the sun from Earth's surface, even at its closest approach. No apocalypse, no wobble, no drama. Just a dimmer, quieter planet that slowly forgets what a real tide, or a real eclipse, ever felt like. Pluto is a step up in size, though step up is doing a lot of work in that sentence. Its surface is a patchwork of water ice and nitrogen ice does something dramatic the moment it gets dragged closer to the sun. It sublimates, jumping straight from solid to gas without bothering to melt first. Move Pluto into lunar orbit, something like 1,000 times closer to the sun than it's used to, and that thin nitrogen crust wouldn't glow softly the way our current moon does. It would boil away into a streaming tail, turning your replacement moon into something that behaves less like a satellite and more like a slow-motion comet parked permanently over your head. Gravitationally, Pluto is still weaker than our actual moon, so tides would shrink and Earth's axial wobble would get noticeably sloppier, dragging seasonal weather patterns out of their usual rhythm. None of that is instantly lethal. It's just unsettling, watching your night sky grow a glowing tail that never goes away, a permanent reminder that the thing up there is quietly evaporating. Now for the dwarf planet almost nobody has heard of, which is ironic, since Eris is the entire reason Pluto lost its planetary status in the first place. When astronomers spotted Eris back in 2005, out in a distant region called the scattered disk beyond Neptune, it looked large enough to qualify as a 10th planet. That discovery forced the International Astronomical Union to sit down in 2006 and finally define, in official terms, what a planet actually is, and the new rules ended up disqualifying both Eris and Pluto in the same vote. Later measurements showed Eris is almost exactly Pluto's width, but about 27% more massive, meaning it's built from denser material, more rock packed in relative to ice. Swap it in for the moon and you get a strange combination. A body that looks nearly identical to Pluto from your backyard, but pulls noticeably harder on Earth's oceans and crust because of that extra density hiding underneath. Same face in the sky, heavier handshake underneath it. Mercury is the one people online love to call safe, and compared to everything else on this list, it basically is. It's only about 1.5 times wider than the moon, cratered and grey, close enough in size that from your backyard you might not clock much of a difference at first glance. But there's a detail most breakdowns of this idea skip entirely. With a body Mercury's size sitting that close, Earth and Mercury would technically stop being a simple planet and moon pair and start behaving as a binary system, because their shared center of gravity, the barycenter, would land outside Earth's own surface instead of buried deep inside it. That's the exact same physics behind Pluto and its moon Charon, and it would kick in here too, whether anyone wanted a binary planet or not. Tides would strengthen a little, storms would get slightly more aggressive, but nothing here rewrites the rules of survival. Out of every option in this lineup, Mercury is the version where you wake up, glance at a slightly bigger grey disk in the sky, and mostly just go about your day. Mars looks worse than it actually behaves. at least at first glance. Picture rust-red light spilling through your window every night instead of pale white, because Mars is coated in iron oxide, the same compound responsible for ordinary rust turning that unmistakable reddish-brown. Mars is both bigger and more massive than our current moon, so its gravitational pull would drag harder on Earth's oceans, flattening small tsunamis down to something more manageable while turning ordinary waves into swells that could genuinely swallow a pier. But none of it happens overnight. Real tidal locking between two orbiting bodies plays out over millions of years, not over a single terrifying afternoon, and Earth's rotation would slow down in tiny fractions over centuries, not slam you into a 16-hour workday by next Tuesday. Mars would absolutely be dramatic to look at, painting your nights a color no human has ever seen the sky wear before, but it would be slow, almost patient, about actually causing you any harm. Venus is where this whole scenario stops being subtle. Right now, it's already the brightest object in our sky after the sun and moon, thanks to thick clouds of sulfuric acid bouncing sunlight straight back at us, and it's roughly 3.5 times wider than the moon on top of that reflectivity. Bring something that bright and that large in close, and true darkness might vanish completely, with Venus lighting up your nights brighter than any full moon you've ever stood under. But a body that large, sitting that near, forces a bigger structural problem. Earth and Venus would form a genuine binary planet system, both worlds circling a shared point in empty space between them rather than one orbiting the other. People assume a binary system automatically means a head-on collision, but researchers running these exact scenarios through orbital simulation software have found something stranger instead. The two bodies often spiral around each other in a slowly tightening dance, and in some outcomes, the entire pair eventually gets flung clean out of the solar system before they ever actually touch. Gorgeous to imagine, structurally unstable, and completely indifferent to whether either planet's inhabitants survive the process. Neptune and Uranus are close enough in size that they basically function as a matched pair for this experiment, both somewhere around 14 to 15 times wider than the Moon. Either one would swallow a massive chunk of your night sky in pale blue-green. And yes, Uranus genuinely does carry a faint hydrogen sulfide smell woven into its upper atmosphere, the same compound that gives rotten eggs their reputation. But the number that actually determines your fate here is called the Roche limit, the distance at which a planet's tidal gravity becomes strong enough to physically tear apart anything orbiting too close, the same mechanism that keeps Saturn's rings from ever reforming into a moon. At the Moon's current distance, a planet this massive would push Earth uncomfortably near that threshold without quite crossing it. Tides would turn genuinely violent, coastal cities would need to retreat inland by miles rather than feet, and ordinary ocean waves would start behaving less like weather and more like an active warning system. Saturn's beauty is the entire reason people love imagining it in our sky in the first place, all pale gold with that famous ring system trailing out behind it like a halo. But those rings exist for a specific, unglamorous reason. They sit inside Saturn's own Roche limit, exact zone where tidal forces are strong enough to shred a moon into loose rubble before gravity ever gets the chance to hold it together as one solid body. Slide Saturn into the Moon's current orbit, and Earth would be sitting dangerously close to that same danger zone, orbiting a planet with roughly 700 times Earth's volume looming overhead. Instead of politely settling into life as Saturn's new satellite, Earth's crust and oceans could start getting pulled apart by the sheer mismatch in gravitational force between the side facing Saturn and the side facing away from it. In the most extreme version of this scenario, Earth wouldn't end up orbiting Saturn as a moon at all. Piece by piece, it would slowly become another ring, one more pale band stretched across a sky that used to be ours. Jupiter is the finale for a reason, and honestly, it earns the spot. It's about 41 times the width of the Moon, so massive that if you actually swapped it in, you wouldn't even be able to see its poles curve away toward the horizon, just an endless wall of orange and cream storm bands filling your entire sky from edge to edge. Earth would instantly become Jupiter's moon in every practical sense, and the side of the planet facing Jupiter would feel a noticeably stronger gravitational pull than the far side, stretching Earth unevenly and triggering earthquakes and volcanic eruptions on a scale nothing in recorded human history has ever come close to matching. But the detail almost nobody brings up in these breakdowns is radiation. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's own, trapping charged particles into belts so intense that, according to measurements from missions like Juno and Cassini, an unprotected astronaut near its inner moons would absorb a lethal radiation dose within a matter of hours. Earth wouldn't just get torn apart by gravity in this scenario. Long before the crust started cracking, it would already be getting cooked from orbit. So there's your full lineup. From Ceres quietly stealing your eclipses and tides without so much as an apology, all the way to Jupiter stripping the planet down to rubble and lethal radiation. And maybe the strangest part of this entire list is that none of it is actually new. Somewhere out past where Mars orbits today, roughly 4.5 billion years ago, a Mars-sized planet already crashed this exact party and rewrote Earth's sky forever, and we simply grew up calling the result normal. If you had to pick one world to gamble your sky on, which one would it be? And which one would you run from the moment it appeared over the horizon? If sticking around for all 9 near apocalypses felt worth it, hit like and subscribe so you're there for the next impossible swap we run.